Okay, number 4. It's kind of getting a little more complex, but it's okay. So Maria throws an apple vertically up. Step 1, draw a picture, of course. We have an apple. It's thrown vertically upward with an initial height. So I'm gonna call this our ground. And this initial height is going to be 1.3 meters. The initial velocity, I'm gonna call this VI. Let's just do VI this time. Of 2.4 meters per second. Again, similar with the last problem, it's saying positive. That's just telling us the direction. It's going upward and it's positive, so that means up is positive. And will the apple reach Maria's friend in a treehouse 5.3 meters above the ground? Okay, I cannot draw a treehouse. I'm going to draw a box. We know the height of this treehouse is 5.3 meters. Similar to all the problems we've been doing, this ball will go up, right? That's how it moves. What else do we know? We know acceleration. It's going down. We're on Earth this time, thankfully. What else do we know? Well, the apple at its maximum height, I'm going to call that V final, I guess. That's going to be 0, right? We've been doing that for the past couple problems. What else do we know? Well, this distance right here, the tree house is 5.3 meters, but we have an initial height of 1.3. So we should be considerate of this distance, the distance the apple actually travels. I'm just going to call that X. Let's see if X is a good letter to choose this time. Step 2, knowns and unknowns. What do we know? We know the initial, which was 2.4 meters per second. What else do we know? We know the overall height. I'm just going to call that capital H. We know the overall height of the tree house is 5.3 meters. We also know, well, we can figure out really easily what X is, right? X would just mean this subtracted by this, H minus 1.3, which would be 4 meters. Okay, unknowns. Oh, and acceleration, of course, negative 9.8 meters per second squared. Unknowns. What do we not know? We don't know time, I guess. We don't, yeah. What else do we not know? I don't know. Okay, step 3, equations. Okay, you can see that. V final equals V initial plus AT. Displacement equals V initial t plus half of AT squared, and V final squared minus V initial squared equals 2AX. You're gonna have to get used to these 3 equations. Step 4, let's solve for what the problem is asking for. First part, will the apple reach Maria's friend in a treehouse 5.3 meters above the ground? So even though we know what this is, with the initial velocity that we were given of 2.4, I want to know if it's going to reach the tree house. So I'm going to try and solve for the displacement. I'm going to call this small h. Yeah? Okay. Because this is like, kind of like, it's not like a hypothetical, but we're kind of working with something like that. So I want to know how far the apple can travel with an initial velocity of 2.4. Let's look at our equations. V final, oh, well, we're looking for the displacement, so we're not even going to bother looking at number 1 because that doesn't have any displacement variables in it. Doesn't matter. Number 2, we have displacement. We know V initial. We do not know the time. We don't know that. So I'm not going to look at number 2. Number 3, V final. We do know V final, right? I forgot to write it down right here. But like all the problems we've been doing, at the maximum height, V final is going to be 0 meters per second. We do know V final. We know V initial. We know acceleration. And we're looking for the displacement. This is x right here. It's just displacement. So we're calling it h over here, just for clarity's sake. Okay, we're going to use number 3. V final squared minus V initial squared equals 2a, this time I'm going to call it h. We're going to solve for h and see if it can reach, if it's greater than 4 meters. That's essentially what it is. Okay, let's solve for h. I'm going to flip my equation to AH equals V final squared minus V initial squared. I'm going to divide both sides by 2a, so I'll get V final squared minus V initial squared all over 2a. Okay, V final, 0. V initial, 2.4 squared. 2a, 2 times negative 9.8. And if you put that in your calculator, you should get something like 0.293 meters. Again, this is how much the apple is able to travel from right here. So if we add this to the initial, what is it, Maria's height, 0.293 plus 1.3, that is not going to be greater than 5.3. That apple is not going to reach the treehouse. So to the answer to question, will the apple reach Maria's friend in a treehouse 5.3 meters above the ground? No. The apple is obviously not going to reach the treehouse. That is the first part. Now let's look at part B. It is, okay, now, if not, with what speed should Maria throw the apple so that her friend can catch it just at that height? So what are we changing? What does that mean? That means our V initial is changing. It's no longer going to be 2.4 because that's what we're going to change when we want to throw the ball up. So I'm going to call this find V, what do you want to call it? V capital N as in new. Yeah, okay. Let's look at our equations. V final, we do know what that is. We just need it to barely reach the tree house. That means it's at its maximum height. That means its velocity is final velocity is gonna be 0. We're looking for VI. We know acceleration. Do we know the time? No, we do not know the time. So we can't use number 1. Let's look at number 2. Displacement. We do know what the displacement is. It's right here. It's the distance at which the apple travels from the initial height of 1.3 to the 5.3 meter high treehouse. We do know the displacement. V initial, that's what we're looking for. Time, again, we can't use time. Let's get number 3. V final, we do know. V initial, that's our answer. 2ax. We all know these values, so I'm going to use number 3. So V final squared minus, it's initial right here, but in our problem this is Vn squared, right? I hope that makes sense. Equals 2ax. We're looking for Vn. How do I want to do this? Let's move v final over to the other side. So we got negative v capital N squared equals 2ax minus v final squared. I do not like that negative sign right there, so I'm going to flip all the signs. Vn squared equals negative 2ax plus v final squared. And now we need to take the square root. Vn negative 2ax plus v final squared. Let me check if this is correct or not. Yeah, I think it looks good. So we got negative 2, acceleration is negative 9.8. The displacement, we know that. Treehouse is 5.3, Maria is at 1.3. We subtracted that and we got 4, right? So the ball needs to travel, it just needs to travel 4 meters. That's all we need. And V final, that's 0, right? If you put that in your calculator, it probably becomes something like 78.4, which if you round it, Vn should become something like 8.85 meters per second.